Hello, hello and welcome to this video. In this video, we will learn a very specific concept about virtual functions, polymorphism and inheritance. So it is really very important, okay? That is why I'm emphasizing that it is really important twice. Now, in continuation with our last video, which we did on inheritance and polymorphism, we will continue with that. So suppose we have a parent class, we have a constructor which prints in parent's constructor and a destructor. Destructors are written with tilde and then the class name. And it prints parent's destructor. Then we inherit from parent a child class which prints child's constructor and child's destructor. Now we create a child object and we use parent's pointer to point to it, and then we delete P. Note that this dynamic memory allocation is not yet done. So do you think there is anything wrong in the program? Note that this object is child's object and this P is parent's. So when we delete P, it will try to invoke the parent's destructor. Okay? But this destructor is not virtual. So it will never try to destroy this child object. Okay? The order of creation is that first parent's object is created, then children object is created. And while destructing the object, first the child object is destructed and then parent object is destructed. But in this case, child's destructor will never be called and it will cause memory leak. So memory leak is when you allocate some memory but you lose the handle to it to recollect memory or free from heap. So we first compile it, and to check memory leak we use valgrind. Okay, so you need to install this, and when you run this it will tell you that all heap blocks were freed. Okay, so did we run this? Okay, so is anything virtual here? Okay, there is nothing virtual here. And P new child. All right, nothing is virtual. Let me compile it again. And we run this. So it says all heap blocks were freed, no leaks are possible. And you see in the output here, the child's destructor was never called. Now suppose we allocate some memory, 10 integers, and we delete them in the child object. Now you'll see the problem. Okay, now you see definitely lost 40 bytes. So whenever you have some cleanup to be done over here in the child object, be careful, memory will not be cleaned up if your parent's base class is not virtual, destructor is not virtual. So what we do is we make it virtual. Now the polymorphism rules will kick in, and when this P pointer will be, destructor will be invoked, it will see that it is a virtual destructor, and then it will be forced to call the children's destructor and memory will be cleaned up. So in long running programs, it is very important that you clean up memory properly. So now you see all heap blocks are free, no leaks are possible. And now you also see that child's destructor is getting called. Earlier it was not getting called, right? Child's destructor was never called here. Let me increase the font a bit. Okay. So in the first call, child's destructor was not being called. Now it is being called and this deletion comes in picture. Earlier this function was never getting executed. Constructor was getting executed but destructor was not. So we had a memory leak issue. We were losing the handle to the I pointer through P. we lost the handle. As long as we have P, we can deal with I. But once we lose P, that is after this line, we can't do anything about P, or rather I. Okay? So it is of paramount importance that your base class destructor is virtual, particularly with inheritance and dynamic memory allocation in children class. Okay. So that's it. There is nothing more to this video. As I said in the beginning, it will be a short video. So also, this is very important in polymorphism and inheritance. Okay. So normally you should not allocate raw pointers like this. But even in any case, even if you use unique PTR or shared PTR, or you allocate some sort of memory in the constructor and the destructor is not called, then that object will be lost to memory. There will be loss of memory if you allocate any kind of memory. Alright. So for example, let's say we take an integer I and we assign it 10 and we don't have this delete. Okay. Let's see, it is not a memory allocation anymore, dynamic memory allocation. So in this case, okay, we had virtual here in the place. So suppose we don't do virtual and there is no dynamic memory allocation. Then it is okay. As long as it is on stack, the CPU will clean it up. It will be cleaned up as long as it is on stack. But whenever you have allocation on heap, it will cause memory leak because this cleanup will not happen. The delete won't be called on the memory allocated on heap. So with this, I will end this video here. I hope that you enjoyed this video and found something useful to your C++ programming knowledge. So thanks a lot for watching the video, and we will meet again with another video on C++, roughly 4 days from now. No guarantees. So once again, thanks a lot for watching the video. I'll take my leave here. You keep learning and have a nice day. Enjoy.